Making strong, high-quality welds on steel takes considerable practice and knowledge of welding equipment and types of metals. You're going to learn how to safely set up your welding equipment, select the proper flame, prepare the metal for welding, and use the best welding technique for the job. The correct method of setting up and using welding equipment is very important, since improper use can be extremely dangerous. First, make sure the cylinders are fastened securely so they can't fall over. Next, crack the valves quickly on each tank to blow out dirt, and check to make sure the regulator inlet connections are clean. Then attach the regulators to the cylinders and tighten the connection nuts firmly. Never use oil on these fittings. Before opening the cylinder valves, be sure the regulator adjusting screws are backed all the way out. Now, connect the green hose to the oxygen tank and the red hose to the MAP gas tank. The oxygen hose fittings have right-hand threads, and the MAP gas hose fittings have left-hand threads. Then connect the other ends to the torch butt. Remember, red goes on the fuel and green on the oxygen. Next, stand to the side of the oxygen gauges and open the valve until the pressure is built up. Then open it all the way. Never stand in front of or behind the gauges because they could blow out and injure you. Then open the cylinder valve one turn. Next, open the oxygen valve on the torch and adjust the oxygen regulator to 6 to 8 pounds pressure. Continue to purge the oxygen for 5 to 15 seconds. Then turn off the torch valve. Next, adjust the fuel line pressure to 1 to 5 pounds and purge the hose up to 15 seconds. Purging the hoses eliminates any mixtures of gases left in the hoses, so no flashback will occur when the torch is lit. Before lighting the torch, attach the proper welding tip for the job. The MAP gas tip has one large hole in the center countersunk to stabilize the flame. Screw the tip to the torch and tighten it down hand tight. Before lighting and adjusting the flame, you should prepare the surface of the metal you're going to weld. Regardless of the type of metal, all surfaces to be welded should be free of oxides, scale, paint, grease, and other foreign materials. An area at least 1 inch on each side of the spot to be welded should be ground clean of foreign material. If the material was flame cut, all the oxidized metal must be removed by grinding or filing. Next, position the metal to be welded. If the metal is thinner than 1/8 inch, it should be spaced apart the same distance as the thickness of the metal. For instance, if the metal is 1/16 inch thick, then the plate should be spaced apart approximately 1/16 inch. If the metal plate is 1/8 inch or thicker, the space should be 1 1/2 times the size of the diameter of the welding rod to be used. Now that the metal plates are properly spaced, light off the torch and select the proper flame. To do this, just barely crack the fuel valve, then ignite the torch with a striker. Adjust the oxygen and gas in successive steps until a slightly oxidizing flame is produced. The slightly oxidizing flame is used for most welding with MAP gas. The inner cone is long and pointed and is surrounded by a dark blue outer flame. If the outer flame has yellow feathers at the tip, it's a carburizing flame. Twist the oxygen valve and the feathers will disappear, yielding a neutral flame. If too much oxygen is applied, the flame will turn from dark blue to light blue. Also, the sound will increase and the outer cone will shorten. This is an oxidizing flame. Now cut back on the oxygen to reproduce a slightly oxidizing flame. The next step in the job is to tack the two pieces of metal together before the final weld is made. Good tack welds include the following 4 factors. First, they must be strong because they're part of the finished weld. Second, they should be approximately 1/4 to 1/2 inch in length. Third, they should be about 1/8 to 3/16 inch in width. And fourth, they should be made on the back side of the area to be welded, so they will not interfere with the finished weld. Keeping these factors in mind, tacking is actually only making small welds. To begin a tack, heat the area to be tacked until the edges melt and begin to puddle. Then dip the rod into the puddle to add sufficient filler metal. The puddle, not the flame, should melt the rod. Angle your torch to about 45 to 60 degrees to the plate and point it in the direction of the weld. The angle of the torch will depend on the needs of the puddle. The greater the angle of the torch, the hotter the puddle. Keep the inner flame cone 1/4 to 3/8 inch from the puddle. Move the puddle along by moving the torch in a horseshoe or circular pattern until the weldment has covered about 1/2 inch in length. Tack each end of the plate. Once the tacks are complete, you can begin welding the joint. Make sure you have adjusted your torch to a slightly oxidizing flame because it's hotter than a neutral flame and will give quicker starts. Make sure you have enough filler rod on hand for the job. When using MAP gas, always use triple deoxidized filler rod for welding. Now heat the edges of the joint until they begin to puddle. Then dip the filler rod and allow the puddle to melt the rod. The flame should be angled 45 to 60 degrees to the plate and should be pointed toward the direction you intend to weld. Keep the torch moving constantly in a horseshoe or circular motion to push the weldment along in an even pattern. Keep adding rod to the puddle, but do not stir it, because oxides will be imparted deep into the puddle. If too much rod is used, the keyhole appearance will disappear and you'll wind up with a straight kerf. The back of the weld will show straight edges and a lack of penetration. If too little rod is used, the joint will not fill up and thin areas or holes will result. If the puddle appears to be too cold and the edges are not melting and fusing, then increase the angle of your torch slightly toward the perpendicular to increase the amount of flame contact. This adds more heat to the puddle. If you're blowing a hole from too much heat as you try to progress with the weld, then decrease the angle of your torch slightly to decrease the amount of heat and add sufficient filler material. When the welding is completed, the finished weld should look like this. The bead should be neat, straight, and level. The ripples, which are the horseshoe-shaped lines in the weldment, should be even and neat. And the edges of the weld should appear to be fused completely with the plate. Poor quality welds will be just as evident as good welds. The edges of this weld are not fused to the plate. This is because the plate's edges were not hot enough and therefore didn't melt and fuse with the filler rod. To rectify this problem, decrease your welding speed to ensure the base metal puddles, or increase your torch angle so that it delivers more heat to the area. This weld is insufficient. It has holes and is irregular. This is due to an intermittent movement of the torch and the irregular use of the filler rod. To rectify this problem, move your torch in a steady rhythm and regularly add the rod as you progress. This weld has a black charred appearance due to improper flame adjustment. A highly oxidizing flame will burn the base metal. Make sure your welding flame is a slightly oxidizing flame. Once you've completed your welding, secure the equipment by closing the torch's fuel valve, then the oxygen valve. Always make sure you shut off the fuel valve first to minimize flashbacks and popping. Then close both cylinder valves. Next, Open the fuel valve and bleed off the MAP gas. Then do the same for the oxygen. Finally, back out both regulator adjusting screws. Remember, making strong, high-quality welds on steel takes considerable practice and knowledge of welding equipment and types of metals. Your first welds will probably look pretty rough, but don't despair. High-quality welds take considerable practice. Good welding.